All right, let's talk about example number 4. Again, we're going to think about all of the steps. Number 1, hammer out, which means using test-taking strategies. Number 2, create a key. 3, find your parents. 4, do the Punnett square cross. And then number 5, the last thing that we're going to do is answer some questions. All right, for number 4, this one's a little bit tricky. It says for tigers, albinism is a recessive trait. So this is the term or the phenotype that we're going to be focusing on, albinism. If I look here, it tells me that it's recessive. If something is recessive, we know it's going to be a lowercase letter because that is the definition of something that's recessive. We also know that it's going to be weak, so we can only see it if it's paired up with another lowercase letter. Then it says a homozygous dominant tiger. So this right here is parent number 1. So I'm going to write P1 so that I don't get confused. And I'm also going to write a reminder for myself. Homozygous I know means the same. And if it's dominant, I also know that it's capital. You guys need to be writing this on your paper as well. We're going to cross that with another tiger. So here's our second parent, who is a carrier for albinism, which means that they're heterozygous. So this is parent number 2. And if they're heterozygous, I know that their 2 letters are going to be different. And then it asks, what is the probability? So I'm looking for a percentage that the offspring will be albino, which means it has to be recessive. Albinos only phenotypically appear when they have albinism or the genes that code for albinism. All right, so let's go ahead and fill in our key. If they are not an albino, we know that albinism is recessive. So the only way to not be an albino is to make sure that we have an uppercase letter. Okay? All right, so here we go. Not albino, I'm going to go ahead and use a capital A. Albino, I'm going to use a lowercase a because I know it's recessive. So let's figure out our parent. Our first parent, P1, is homozygous, so it has to be the same, dominant, 2 capital letters. So big A, big A. Our second parent is a carrier, or we can say that it's heterozygous, so they have to be different. So I have to have 1 capital letter, 1 lowercase letter. Let's go ahead and fill in our Punnett square. I'm going to put the first, whoops, don't do that. I'm going to put my first parent here, 1 in each box, and I'm going to put my second parent here. All right, so let me go ahead and do my cross. I'm going to have big A in this box, big A in this box, big A, little a here, big A, little a here. I'm also going to go ahead and fill in what my phenotypes are going to look like. So if I'm big A, remember not being an albino is capital. An albino is recessive, so it's going to be a lowercase. So I have 2 capital letters here, so I'm going to write not. So this is not an albino. This is going to be the same thing because they're exactly the same. Here I have 1 big A and 1 lowercase a. Something to remember, this guy is not strong enough to overpower this guy. So whatever this codes for, not albino, is what we're going to have. So I'm going to put not here again, and I'm also going to put not here. So we need to ask ourselves, let's look back up at the question. It's asking, what is the probability of getting an albino? The only way to be an albino is to be lowercase, lowercase. So do we have any lowercase, lowercase in our Punnett square? No. So what's the probability of these 2 parents having a baby that has albinism? It's going to be 0%. It's impossible for them to make a baby who has this particular disorder.